Everybody, we're on lesson 8 for trigonometry part 1, page 559. So in the last lesson, lesson number 7, we looked at the a value and the b value for sine and cosine. We're only going to do this for sine and cosine. We will not do it for tan. All right, so a and b are vertical stretches. For a is a vertical stretch. B is a horizontal stretch. This lesson, we're going to look at C and D. And if you remember, C is a horizontal translation, which we abbreviated as HT. Basically, it moves the graph left or right. And D was a vertical translation, which means we go up or down. Okay. So all you have to do is tell me what we have done in these two graphs. We start with y is equal to sine x. And we rewrite it as y is equal to sine x minus 30. That means our C value inside the brackets with the x is 30 degrees, which means we went right 30 degrees. We took our sine graph and shifted it right, and hopefully you remember what the sine graph looks like. That is sine. We shifted it right 30 degrees. This is not by any means an accurate sketch, so it would look like that. And that would be 30. Etc. And this would be, if that's 360 plus 30, that would be 390. So we just moved the whole graph right. And what you have to remember is the sine graph goes on forever in both directions, but you get the idea. All right, so the second one, sine x plus 2. What's our d value? We went up 2. So we took the sine graph. I'm just going to do it on the same one here for color. We moved it up 2 units. So now it looks like that. So it's not shifted left to right, it's just shifted up. All right. Sine x plus 60 minus 1. Our d value is minus 1, so that's down 1 unit. And our c value, remember, is negative 60, which is inside the bracket 0. Which means we went left 60 degrees. We have 2 translations there. Last one, y minus 45 is equal to sine x minus 45 degrees. First thing you have to do is move that 45 over there. So it becomes 45. So now we know our d value is plus 45, so it's up 45 units. Our c value is 45 degrees. That means we went right 45 degrees. And just because trig is trig, instead of calling these horizontal translations vertical translations, all right, they call them horizontal phase shift for your c value and a vertical displacement for your d value. I don't care if you remember those. Somebody down the road, if you go on in math, probably will, but most people won't. They will know what you mean if you say a horizontal translation or a vertical translation. All right, so we're quickly going to do this. Sine x, that's the most basic graph, so there is no shift left or right. Sine x minus pi over 4, that's a c value, so we went right. We didn't do a vertical. Sine x plus 5, that's a d value, so we went up 5. We do a translation. This one, remember, move the pi over here, it becomes negative pi. So we went down pi units. 2 pi over 2 is positive, so that means we went left. 3 pi over 2. So in other words, the c value moves you left to right, d value moves you up down. That's really all they're getting at here. So we don't really need to worry about that. Hopefully that brought back memories, good memories of the very first unit we did, transformations. Okay, so let's look at these tables. This is just summarizing what we did. What do C and D do? And we know they go left, right. This formula is in the table, so I'll talk about it there. Okay, so now we have everything. We have an A value, a B value, a C value, and a D value for both sine and cosine. There's a separate table for tan. We'll talk about that in a sec. Remember from the previous lesson, the amplitude of the graph, or the function, is the absolute value of A. In other words, it's the positive value of A. Even if it's negative, it's still the positive value. If you're calculating it from a graph, use this formula, max minus min divided by 2. So that's if you have a graph, and we're going to do examples of that. The period of sine and cosine is 360 divided by whatever your b value is, the absolute value, so always positive, or 2 pi divided by b if you're doing it in rads. Horizontal phase shift, go left to right. We're going to talk about how to calculate that. The d value, the vertical displacement, it's positive you go up, it's negative you go down, blah, blah. But here's the formula to calculate it from a graph. And the trick of it is, the only difference is from this formula up here, this one is minus for the amplitude, and this one is plus, max plus min divided by 2. All right, that's for sine and cosine. If you have a tan, we are not going to do tan graphs, but we're not going to determine the equation of a graph for tan graph. I can give you examples like we did earlier, and you'll see that in a bit. I'm asking you what A, B, C, and D are, but amplitude you cannot calculate from a graph, okay? Because remember, the tan graph goes on forever up and down, so there is no max and min, so you can't calculate it. The A just represents a vertical stretch by a factor of A. So if there's an A in the equation, you just say it's a vertical stretch by whatever A is. Remember, the big difference is the period for tan is 180, or pi for sine and cosine is 360 or 2 pi. C is the same, goes left to right. D value goes up and down, but you cannot calculate it because there is no max or min. Can't calculate from a graph because no max or min. Same reason you can't calculate, right? Same reason you can't calculate it, the amplitude. All right, so normally I would say no those tables, but obviously you have them in your books, so use them on the assignments. All right, consider equations of the form blah, 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 blah. And okay, write a cosine function having a horizontal phase shift 75 degrees right. So cosine A and B are 1, so we don't need to worry about them. They don't say anything about going up or down, so D is 0. And our horizontal phase shift is 75 degrees right. C is 75. Remember, it is x minus c, so this equation is cos of x minus 75 degrees. And that's it. All right, sine function, horizontal phase shift, a 3 pi over 5 radians left, and 4 units up. There's our d value, plus 4. This one, our c value. Now, remember, if you go left, you're negative, but when you put it into the equation, here, it's x minus c, so you actually get sine x minus a negative, so it becomes positive 3 pi over 5, and then plus 4. There you go. All right. Now you're just going to tell me you have the equation. You just have to tell me what each of these things are. So amplitude, period, horizontal phase shift, which is D value, vertical displacement, which is D, amplitude number is A. So what's our A value? Amplitude is 2. We'll leave B, the period, to the end. Our C value is negative pi. Therefore, we went left. It's just that since a is 2, no, they don't ask for it, so amplitude is 2. Our d value is negative 4, which means we went down. Okay, now we're going to find the period. We did this in the previous lesson. Remember that the period is equal to, we do it in rads or degrees. We'll do it in rads, since this is rads, or pi. 2 pi over b. Okay, so what's our b value? It is 3. So our period is 2 pi over 3. That's it. Okay. Hopefully you remember pi over 3 is 60. 2 times 60 is 120. The period is 120. Not that they ask you that, so. All right, second one. All right, all fractions. Amplitude is 2/3. Remember, we just take the positive. We don't worry about the negative. We can do period. Period is equal to 2 pi over b. What's our b value? It's 1/4. 2 pi over 1/4. You flip the bottom fraction. 2 pi over 1, just for the sake of it, times 4 over 1, which is 8 pi. There's your period. And that's because since we have a quarter, that's a vertical expansion by 4. So you multiply 2 pi by 4. C value is pi over 12, which means we went right, and our d value is plus 3, so we went up 3. Okay, hopefully this is bringing back memories. Just because I feel like changing colors. All right, same thing, but we get a bit of a wrinkle here. The b value has been multiplied in, so hopefully you remember by looking at these equations here, the b value is always separate from the x minus c. So we need to factor it out. So we rewrite it as 2 sine 3 x plus pi over 3 minus 4. So I factored out a 3. If you want to check it, you could always dump this back in to see, make sure you get it. All right, amplitude 2. Period is 2 pi over b. Our b value is 3, so it's 2 pi over 3. Our c value is pi over 3, which means we went, it's negative pi over 3, sorry. That means we went left pi over 3, or 60 degrees. And our d value is negative 4, which means we went down. Okay. This one, same thing. Factor out a 2. So we get negative goes 2 bracket x minus. If I pull a 2 out, I should get divided by 2 pi over 4 plus pi. Remember, if you want to check, dump it in. So our amplitude, what number is in front of this? It's negative 1, but you never use the negative, so our amplitude is 1. Our period is 2 pi over b. B value is 2. 2 pi over 2 is pi. Period is pi. Our c value is pi over 4, which means we went right 45 degrees, or pi over 4. And our d value is pi, which means we went up pi units. Okay, hopefully that wasn't too bad. This bit is just pulling stuff out of the equation. I would like you to do questions 1 and 2. And when you finish those, you can come back for the fun part. Good luck. Okay, hopefully that wasn't too bad. This is where things get tricky, so please bear with me. They can get a little dicey, but we can figure it out. So each one of these graphs, I'll zoom in here. All these graphs are the same. You can see them, they're all the same. We're going to write 4 different equations for them. All right, and they all produce the same graph. So you're going to have to bear with me here. What you're going to have to remember is we're going to do 2 sine graphs, we're going to do 2 cosine graphs. Now remember the basic sine graph looks like this. Starts at 0, goes like that. These are all in rads, so I'll do this in rads. Pi, or 2 pi, that's pi. Remember it goes on forever like this. Negative pi, and that's 1, negative 1. Okay. All right, so all we have to do is figure out our A value and our C value. Well, what's A? If you remember the table, the A value is max minus min divided by 2. Well, what's my max? 4. What's my min? Negative 4. So that's 8 over 2, which is 4. Look, if you see a graph that has a max of 4 and a min of its that negative value, it's always just the positive of those two. I mean, if you do the formula, you'll see that, but it's always going to be 4. So every one of these has an A value of 4. Let's fill that in right now. 4, they're all the same graph. Okay, it's the C value that changes depending on what type of graph you're doing, sine or cosine, and whether you want A to be positive or negative. In this case, we want A to be positive, all right? Which means we have not done a reflection, which is good. So, if you look at the original sine graph, which is this thing right up here, sine of x, the key part you have to remember for this is, if you look at the origin, the graph is going up, and it's halfway between 1 and negative 1, right? That's the midpoint, all right? And the graph is rising. So what you want to do for this graph to see how it's been shifted left or right is you go to the origin and you find the closest part of the graph that is rising, all right? So if you go to the right, you hit this point. Is the graph going up? Yes, it is, right? Because the graph is coming like this and rising up like that. If you went to this, the graph is actually falling because you always read a graph left to right. Okay, so this is the closest point right here. Well, what is that shift? The next thing you have to do is figure out what each line is worth. Okay, it's 2 lines over, but what is each line worth? The easiest way to do that is to locate pi and count how many lines there are to get to pi. 1, 2, 3, 4, 5, 6. Okay, so it's 6 lines to get there. So each line is pi over 6, right? Does that make sense? That is pi and it took 6 lines to get there, so pi divided by 6 is what each line is worth. Then what we do to find our C value is we just calculate how many lines there are. 1, 2 to get to the graph. 2 times pi over 6. What's 2 divided by 6? 3. That is our C value. The equation of this graph is y is equal to, remember our A value is positive, 4 sine x minus pi over 3. That is the equation of that graph. 1 of 4 anyway. Or 1 of 4 in this case. All right, so we're going to go down to the next one. We're still going to do a sine graph, but now they're going to say A is negative. So now you got to think about, so A is going to be negative. Our amplitude is still 4, except when we write it in the equation now, we're just going to make it negative, right? Because when you're doing the amplitude, you always take the positive value of the A. So I will say A is negative 4. And that's only because they have forced us to do this. The C value is where things change, okay? So what you have to remember is, I'll quickly sketch the sine graph. Well, here's the regular sine graph. At the origin, it's going up. We just talked about that. That's how we got this one. Now, if I'm going to sketch negative sine of x. That means I take this graph and I flip it over the x-axis. Okay, it's a vertical reflection. It's a reflection of the x-axis. So what does that graph look like? It now looks like this. I'll draw it in after. Instead of rising up, it is now falling at the origin. Okay. Look, I screwed up the rest of it, but all I really care about is, that's 2 pi. That's negative pi. All you care about is this origin here. And this is, the graph is falling now through the origin, which is halfway between 1 and negative 1, the midline. This is negative sine of x. So if we're going to make our a value negative 4, you go to the origin and you find the closest line that is falling. If I go to this line, that's the one we used above, that's going up. So I can't use that one. So I have to go to this one. You can go left, that's fine, no problem. And the graph is falling. Well, each line is worth pi over 6 because this is the exact same graph. It's up here. How many lines is that? 1, 2, 3, 4. C value 4 and pi over 6. Which, like fractions, it will reduce to 2 pi over 3. So now the equation becomes negative 4 sine x, but we went left. Okay, that's negative. So that becomes x plus 2 pi over 3. Because it's x minus your c value. Minus a negative becomes positive. All right, so now you just saw two different equations generate the same graph. At least they're both sine graphs. Now we're going to look at cosine. All right, the amplitude is the same. We're dealing with a positive number here. Okay, so my a value is 4. The equation is going to be 4 cos x, and then we just have to figure out the c value. Cosines are actually the easiest ones. You think of a cosine, the regular cosine graph looks like this. Oops. There it is. That's 2 pi. That's a start. It's a period of 2 pi. That's pi over 2 pi. That's 3 pi over 2. Negative pi over 2 if you want. The thing about the cosine graph to find your c value is all you have to do, find the max. It's where the max has been shifted left or right. So you just find the closest max. Excuse me. Which one is closer to the origin? Well, it's obviously this one. Each line is worth pi over 6 because it's the same as the others. You just count the lines. 1, 2, 3, 4, 5. So the c value is 6 to the right, so it's positive, which becomes x minus 5 pi over 6. Okay. Now, a has to be negative. Just they've defined it that way. We just put a negative our a value. The equation is going to be negative 4 cos x. Find our c. Well, if you take your cos graph right up here and you do negative, so this is cos of x. If I sketch negative cos of x, this max flips to a min, and you get this. Okay? And this would be pi over 2, 3 pi over 2, 2 pi. Okay, So then all you have to do is look to see where the min is. Because if our a value is negative, our min has been moved left to right. So you just find the first min, which is right there. Min is negative 5/6. So this becomes 5/6. All right. So we have four different equations. Four sine x minus pi over 3, negative 4 sine x plus 2 pi over 3, 4 cos x minus pi over 6, and negative 4 cos x plus pi over 6. They all give us the same graph. You can plug them in the Desmos, you will get the same graph. Okay, so that's pretty cool. Unfortunately, students usually don't like it because it's four different things to remember. My theory is just pick one and go for it. If you start to do enough questions, you will see how this all falls together. I'm going to show all four in the next examples, but the reality is if you know how to do one, that's good for Math 12. If you're going on, yes, you need to know how to calculate all of them. All right, we're going to flip to the next page, and we're going to do these guys. And we're going to determine the equation. Because in these ones, we had no d value. There was no d. D was equal to 0. Okay? This one has d, but d is actually easy. The only hard letter to calculate is c, the phase shift, left and right, the horizontal phase shift. Right? So, because remember, our a value is max minus min over 2. Our d value, when we're doing sine and cosine, is max plus min over 2. D value is also the midline of the graph. Okay, and I'll show you what that means in a sec here. Period 2 pi over b, or 360 over b. And then C, you have to follow these rules here. So, but these three are the easy ones to find. Amplitude of this graph. Max is 1, min is negative 5. 1 minus 5 over 2 is 6 over 2, which is 3. And then that's our A value. Period. This can be a little tricky, but we did it in the last one. Period is peak to peak, right? So that's the easiest way I find it, is peak to peak. Now, the trick is, what is each line worth? But I showed you that in the previous example. Find pi, which is right there. How many lines to get to pi? 1, 2, 3. So what is each line worth? Pi over 3. So each line is pi over 3. Now, how many lines are between the peaks? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. So that means a period is 12 times pi over 3. What's 12 divided by 3? That is 4 pi. Okay. The period helps us calculate our b value. So I write 4 pi is equal to 2 pi over b. You switch the b and the 4 pi. 2 pi over 4 pi. You're going to get 1/2. That's our b value. Okay. The minimum horizontal phase shift, that's your c value. We'll do that last. The vertical displacement, that is d. Remember, that is this formula. Max plus min divided by 2. Well, we know our max and our min. 1 plus negative 5 divided by 2, which is negative 4 over 2, which is negative 2. Okay, this is the midline, like I said up before. Our midline is negative 2. And if you look at it, that cuts the graph in half vertically. It's 1, 2, 3, and it's up. 1, 2, 3, and it's down to the peaks or the troughs. Okay, so that's what that is. That's your D value. Okay, so now we have, is this a sine graph? Yeah, sine. So we have y is equal to a sine x minus c plus c. Find a way. They tell us a has to. So it's 3. Our b value we calculate is 1 x. We'll calculate that at the end. That's our d value, which is negative 2. So we have everything except for the c value. Now, just like on the previous one, it's sine x is greater than 0. Remember, we go, I'll just redraw it here. Sine graph looks like this. All right, what's happening at the origin? It's a rising. And if you think about it, that's 1, that's negative 1. This is the midline, okay? This is why the d value is important. So what you have to do is go to the midline of the graph, which we calculated, 2, okay? Go to the origin, find the closest part of the graph that is going up, right? And that would be this one. This part of the graph is rising. If you went to here, this graph is falling, okay? Could use this one because it is rising, but they want the minimum horizontal. So you always want the closest one, which is going to be this one. Well, that's 1 unit left. What's each line worth? Pi over 3. C value is negative pi over 3, which means this is plus pi over 3. All right. Now, they want to do the same thing, so they want the a value less than 0. Negative. Everything's the same, except c will change, and the a value becomes negative. So you just write negative 3 sine 1/2 x. We'll deal with the c value because that does change. Minus 2. Okay. Now remember, this is sine of x. If we did negative sine of x, the graph flips. And what's happening at the origin? We are falling through the midline. Now, find your midline. Find the closest shift where it's falling. There's that one going down. And there's this one going down as well. Which one's closer? It's that one. How many lines to it? 1, 2, 3, 4, 5. And each line is pi over 3. So the c value for this one will be 5 pi over 3. And we went to the right. So it's minus 5 pi over 3. The only two things that change when you make a negative is a value, negative, and the c value. Whoops. The c value switches as well. Okay. Guess what we're doing? Same graph right below it, except we're getting cosine. Is the a value going to change? No. Is the period going to change? No, because it's the same graph. Period is equal to 4 pi, which means our b value is 1/2, just like above. The c value will change because it's cosine. The vertical displacement will not because that's max plus min. So our d value is negative 2. All right. Well, we can write out the equation. Give it in green. A cos b x minus c is c. And this is the positive one. B cos b value 1/2 x. We'll deal with c in a sec. B value minus 2. Now, cosine graphs, remember, they look like this. They have a max at the origin. So the only thing you have to do, you don't care about the midline, you don't care about anything. All you do is find the closest max to the origin, which is that one. And it's 2 units over. Since this is the same graph, each line is worth pi over 3. So C value 2 times 5. I went to the right. Okay, that's to the right of the origin. X minus 2 pi. And that is the equation. That's what they're going to ask us to do. They're going to ask us to do it in where a is negative. Well, that's easy. Make a negative. Is the same. The c value, what you get that. But the negative, the d value does not. Okay. There's your cos x. If I say negative cos x, that graph flips over the x-axis. And now it looks like this. And we have a minimum at the origin. So to find the phase shift, you don't look from axis, you look for the closest min. Obviously, this one is the closest. 1, 2, 3, 4 units to the right. So our c value is negative 4 pi over 3. When you put the equation, becomes 4 pi plus 3. Okay. That's a lot of information. Quick summary. The A values are easy to find. It's just a formula. B value formula. Period is just a formula, or sorry, the B value is just a formula. What is this? 2 pi over B. It's the C value you have to think about. And the only thing you really need to think about is if you're doing sine, do a bit of this on this page. So if it's a sine graph and A is positive, you look for a rising midline to find the shift. Because if you remember a sine graph with an A value that's positive looks like that. And so you've got this midline rising to the origin. Okay, so that you go to the midline and you find which way left or right. Here's the midline, which way left to right to find the rising, and it was right there. If A is less than 0, in other words, it's negative, you're looking for a falling midline. So midline, you flip that graph, it now looks like this, and you've got a falling midline to the origin. Okay, and that was midline. The falling part was this one. This one, that one's further away. You always take the closer one, which was that one. Okay, so that's sine. Cosine. Okay. For a cos graph, if A is greater than 0, it's how has the max shifted from the origin. The cosine graph looks like that. It has a max at the origin. You could say it's less than 0, it's how min shifted. Is now looks like that. Cosines students seem to find easier. So if you look at this one, A greater than 0, just find the max, how close is it to the origin, basically. And I don't mean this origin, I mean to the line that represents the origin, okay? The y-axis. And if A is less than 0, you're looking for the minimum, this point right here, which was this one in this graph, okay? All right, hopefully that was okay. Oh, and then I would get you to do questions just 3, A, and B. It's going to ask you to do 4 different graphs. Basically, it's going to ask you to do something just like this bit that we just did. Okay. And this did not photocopy very well. My apologies for that. But we can still do it. These formulas right here are just saying if y is sine b x minus c plus d. And that's the cosine version. Okay. And I'm saying which of these parameters affect the domain. Affect the domain. The domain is set by you. Remember, the domain for one of these graphs, it goes on forever in both directions. So none affect the domain. What affects the range? Well, if you think about it, either the sine or the cosine graph, doesn't matter. They oscillate between 1 and -1. All right. So the only thing that would change that is an a value of vertical stretch or a shift up or down. The amplitude, well, that's pretty straightforward. The a value. Period, the only thing that changes the period is, sorry, I meant to squish it in, is your b value, because that is a horizontal phase shift. That's your b value, and this says the zeros, which are the x-intercepts. Well, the b value will do that. The c value, shift left or right, and a d value moving up or down. So that would be b, c, and d. Change those. The only thing you need to remember from this bit is if you're trying to find the min of a function, right? The two letters here that affect it are a and d, and they're going to be a plus c and negative a plus d. One of these will be the max. This is how you find the max and the min of a function. So when they ask for the range of a function, and if you can read what they have here, but what it says is 3 sine 2x minus pi minus 4. I want to know the range. Well, just do a plus d. There's my a, there's my d. 3 plus negative 1, and do negative a, because a sine graph, remember, is a to negative a. Negative a plus, so negative 3 plus negative 4, negative 7. So the range of this graph is y. The largest value is negative 1, the smallest value is negative 7. Okay, the only question I want you to do is number 7. That was a long lesson, a lot of information. Please go through it slowly and ask questions if you don't understand. This is the end of Trig 1. I'm not going to do the applications. I'm going to do it as a bonus lesson, so if you want to watch it, but I will not test anything from that. I will expect you to be able to determine the equation of a graph, but I'm not going to give you an assignment on this unit. I'm going to do an assignment on Trig 2, and we're going to do it all together. But I will give you some examples of stuff I would expect you to know. Anyway, good luck, and let me know if you have any questions.